In this section, we'll be talking about polynomials. So a polynomial would be something of this form right here. And you might see it like a little bit more in a traditional form where it's something like 3x cubed minus 2x squared, stuff like that. But this is kind of just the general form. So notice this would be degree n. That would be the highest degree of any of the terms. So the exponent given. So for instance, on this example, what is the degree of this polynomial? Well, we look at the powers of x. So we've got 3x to the fourth plus 5x cubed minus 7x squared plus 0.4x plus pi, which is just a constant term. So in that case, we see that the highest degree of x is 4. So we would say that is degree 4 for that polynomial. And the second part B there, that just has an x, no other higher powers. So if it's just x, you may think of that as like x is x to the first power. So in this case, this would be degree 1. And you might recall also from last unit that this is like the equation of a line. So linear polynomial would be degree 1. Okay, so some vocabulary here. The terms are separated by pluses and minuses. Okay, so for instance, there's a term, there's a term, there's a term. Right, and so there are 1, 2, 3. This has 6 terms. Okay, and if you're talking about like terms, that would mean that the variable parts are exactly the same. So that means that they would have the same variable and the same exponent. Okay, so I'll circle with the same colors. The 15x and the 3x would be like terms because they have the same variable part. The y is, that's actually, there are no other ones like that. But here you see the x squared y and x squared y. So those are like terms. And then the negative 2y doesn't match up with anything, and the 5 doesn't match up with anything. So we'll see some examples where we combine like terms. So just to highlight that the like terms means the same variables with the same powers. All right, so if we were going to evaluate a polynomial, we've kind of done this with some other formulas before. Essentially, you just plug in the value for x in place of the variable. So this would be y equals 5 times, remember you open up the parentheses, something cubed, plus that something, and then minus 1. So I'm just giving a place to plug in the number for the x. So in this case, this would be 2 cubed is 8, so 5 times 8 plus 2 minus 1 would be 40 plus 2 minus 1, giving us 41. So when x is 2, y is 41. So that could be an ordered pair for plotting the points and such. So you got to be a little bit careful here. We talked about this before, especially when you have negative numbers. So if I were plugging in now negative 2, this would be 5 times something cubed plus that something minus 1. And then we say, okay, we're going to plug in a negative 2. Now that makes a difference here for the exponents and order of operations and everything. So that's why I'm real careful about the parentheses. All right, so in this case, negative 2 cubed would be negative 8, since it's an odd power. So 5 times negative 8. And then plus negative 2 would be the same as minus 2, minus 1. So negative 40 minus 2 minus 1. Looks like that would be negative 43. And this next one would be pretty similar. I'll just kind of leave that for you to do on your own. Plug that in. Actually, there's, you know what, there's a little trick to this one to watch out for. So let's take a look here. So if I plug in the formula, there's a negative in the formula. And then x will be raised to the 100th power plus x to the 50th power. So the part I was saying was a little bit tricky was the fact that I've got that negative 1 in parentheses being raised to the power of 100 first. So the part that's you got to be careful on is make sure you do that exponent first. Don't think of that as a double negative, because that negative here is on the outside after you do the exponent. So in this case, a negative 1 to the 100th power would just be negative 1 times negative 1 times negative 1. Might get a little bit confusing, but really it's just going to be a 1, whether it's a positive or a negative. But since it's an even power of 100, we know that's going to be positive. However, there's still the negative, that one I pointed out with the blue arrow. There's still that negative out in front from the formula. And then negative 1 to the 100th power would be 1. And then the negative 1 to the 50th power would also be a positive since it's an even power. So negative 1 plus 1 is 0. So you do got to watch the signs there. All right. So to add or subtract polynomials, that would be the combine like terms. Combine like terms. All right, so let's highlight those. I'm looking for the ones that have something in common. So I look at the first, 5x to the 6th. Are there any other 5x to the 6th? Or any x to the 6ths? I'm not seeing any, so it does not change. I see 3x cubed. Are there any other x cubes? And in fact, there are. Okay, that's 7x cubed. So that's a plus and a plus. So plus is going to keep all the signs the same for that second polynomial. So this would be 3x cubed plus 7x cubed to be 10x cubed. I look at the squared, x squared, and I see an x squared. So that would be negative 2x squared plus 5x squared. So that's going to be plus 3x squared. Notice when you're adding like terms, the variable part stays the same. It's just telling you how many of those x squareds you have. The exponent only changes when you multiply. Okay, so we'll see that in a later section. What's next? We've got an x, but there are no other plain x's. So that's just going to be a plus x, doesn't change. A constant term, it looks like we've got a negative 7 and a plus 1. So negative 7 plus 1 would be negative 6. And looks like we have one term that we hadn't accounted for yet. So that's just going to get added on, plus 4x. So this would be, plus 4x to the 4th. This would now be combined. And the order here, it's actually okay like this. Sometimes you might see it in descending order. So if you wanted to write this as 5x to the 6th plus 4x to the 4th, you see, and just kind of count down your exponents. Sometimes that's nice just for organization purposes. Either one of those answers would be fine. All right, so for the next one, notice there's subtraction. So in that case, you need to distribute that negative to all of those terms. So let's rewrite this. This would be negative x to the 4th plus 10x cubed plus 0.5x. But now that negative gets distributed, so minus 4x to the 4th. Then minus the negative would be plus 7x cubed. Then minus 8x squared minus 1.5x and minus 6. So notice the sign changes on each of those. All right, so the x to the fourths can be combined. That's negative x to the fourth minus 4 more. So negative 1 minus 4 would be negative 5 x to the fourth. Looks like we got some cubes. So that would be plus 17 x cubed. I'll go ahead and do this in descending order. Got the x squared term, nothing to combine it with. So that would just be negative 8x squared. And then you got the x's. So 0.5 minus 1.5 would be negative 1x, or in that case I could just write negative x. And then finally the last one, minus 6. All right, so here kind of a little bit more of the same. I'm not going to work out this entire one, but just remember to distribute that negative and then combine the like terms, okay? And then in terms of the degree, notice the highest power of x here is x to the fourth, so degree would be 4. And then I'll let you kind of do the simplification. I'm going to do the next one here, though, because this one has some numbers. So the 5 gets distributed. So that's 5x to the 7th plus 5. Then the 4 gets distributed to all of those terms. So plus 4x cubed minus 8x squared. And then plus 12x plus 4. And it looks like the only like terms here are just the constant terms. So just a quick rewrite, 5x to the 7th plus 4x cubed minus 8x squared plus 12x, and then that constant term would now be plus 9. All right. And one other thing, you don't see this a whole lot in like kind of determining the degree of multivariable polynomials. So I'll just mention this a little bit in passing. The degree of a multivariable formula would be the sum of the exponents and then find the highest degree. So for instance, that y would be like x to the 1, y to the 1. So the 1 plus 1 would be degree 2, okay? So whereas the others are just standalone, so it looks like degree 2 since the x to the 1, y to the 1, if you sum those exponents, you get the degree. So for the next one, that would be on x squared, y to the first, so that would be kind of a degree 3 for that term. 2 plus 2, that would be degree 4. That's only degree 1, degree 0. So the highest one would be degree 4 for the multivariable.